Hello, welcome to the video. In this lesson, we're going to be looking at section 7.3, where we're going to be proving that a quadrilateral is a parallelogram. So the question that they pose to us is, how can you prove that a quadrilateral is a parallelogram? Well, there are several theorems that are going to help us make that conclusion. But one of the things that the most general sense is if you have a parallelogram, essentially a parallelogram starts out as two sets of parallel lines. So the opposite lines on each side of a parallelogram are parallel. And then there's other things that we can conclude because those two sets of lines are parallel. First, we have what is called a parallelogram opposite side converse. So they say that if both pairs of opposite sides are congruent, we can say that they are in fact a parallelogram. And also we have opposite angles. So if you have opposite congruent interior angles of a quadrilateral, we can also say that that is also a parallelogram. With that, it says here that an amusement park ride has a moving platform attached to 4 swinging arms. So this is the diagram here. The platform swings back and forth, higher and higher until it goes over the top and around in a circular motion. In the diagram below, AD and BC represent 2 of the swinging arms. So AD is right here, BC is right here. And DC is parallel to the ground L. So DC is parallel, so they showed us with the parallel signs here. Great. They want us to explain why the moving platform AB is always parallel to the ground. Well, we can conclude that this quadrilateral ABCD is a parallelogram because I have congruent sides here and I have congruent sides here. So by the parallelogram opposite sides converse, I can say that this is a parallelogram. And going back to my first statement on the first slide, I have, because it's a parallelogram, that means I have 2 sets of parallel lines. And since DC is parallel to line L, I can say that AB is also going to be parallel to line L uh, due to transitive property. Okay, so here it says in a quadrilateral WXYZ, they give us some measurements of angles. W is 42, X is 138, and M is 42 degrees. They want us to find the measurement of angle Z, and they want us to, they're asking, is WXYZ a parallelogram? They want us to explain our reasoning. So try to draw out a diagram. So I'll go W, X, Y, and Z. So we got what? This is 42 degrees. X is 138 degrees. Y is 42 degrees. And they're trying to figure out what Z is. Well, since these two opposite angles are congruent, and we also know that if I were to take the sums of all these angles, this quadrilateral should be 360. So if I subtract it by 138, subtract it by 42, subtract it by 42, I would also get 138. And so I have two opposite uh, congruent angles. That means I can use that parallelogram opposite angles converse. So I can say, yes, WXYZ is a parallelogram. For what values x and y if quadrilateral PQRS is a parallelogram? Um, so here we got if it's that means that this and this are the same and this are the same. So for that to be true, I'm going to say that 2x minus 1 we set equal to x plus 9. Subtract x to both sides, I get x. Subtract, add 1, I get what? 10. So x is 10. For the other one, I have y is equal to, well, I just found out that x was 10, so it's going to be 10 plus 7, which is 17. A couple more theorems that we get to look at. One of them is an opposite sides parallel and congruent theorem. So it says that if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So if you notice, the same line segment can be both congruent and parallel. We can say that it is a parallelogram. And then the second theorem we have here is this: if the diagonals of a quadrilateral bisect um, each other, then the quadrilateral is a parallelogram. So you notice here they meet at a certain point, and that certain point is the midpoint of both BD and AC respectively. So here it says the doorway shown is a part of a building in England. Over time, the building has leaned sideways. Explain how you know that SV is going to be equal to TU. So they want to know if how we know SV will be equal to TU. So those two sides there. So what we can conclude here is, well, we know that ST is congruent to VU, and we also know that ST is parallel to VU, and because of the use of that opposite sides parallel and congruent theorem, we can then say that SV will be equal to TU because they are in fact parallelograms. Here it says, for what value of x is quadrilateral CDEF a parallelogram? So because they're diagonals, they have to bisect. That means whatever this measurement is, this has to be the same. So I go 5x minus 8, set that equal to 3x. Subtract 2x, 3x both sides, you get 2x. And then I'll add 8 to both sides. So I got 2x equals 8. Divide both sides by 2. X is 4. So x would have to be 4 for CDEF to be a parallelogram. Here it says, for what values of x and y is quadrilateral ABCD a parallelogram? They're asking you to explain. So for this to be a parallelogram, I need opposite opposite angles to be congruent. So for that to work out, I would have to say that 3x minus 32 would have to be equal to 2x. So if I subtract 2x to both sides, add 32, x would have to be 32. For the other opposite angles, we have y. So we have y plus 87 is equal to 4y. I'm going to subtract y to both sides. So 87 is equal to 3y. Divide everything by 3. Y would equal 29. All right. So the explanation is because of the parallelogram opposite angles converse. This is when x is 32 and y is 29. It is in fact a parallelogram. So here it says for what value of x is quadrilateral MNPQ a parallelogram? Well, it needs to bisect, so this distance must be the same as that distance. So 2x must be equal to 10 minus 3x. Add 3x to both sides, so I get 5x equals 10. Divide everything by 5. X is 2. So the explanation is because parallelogram, diagonal converse, since those two line segments must bisect each other. In order for them to bisect, x would have to equal 2. For this coordinate plane here, they're asking is to show that quadrilateral ABCD is a parallelogram. So there's several different ways you can go about solving this. What I'm going to do is I'm just going to see if AB is parallel to CD, and I'm going to see if AD is parallel to BC. If those are parallel, then I can say that that quadrilateral is in fact a parallelogram. So in order to figure out in a coordinate plane if two lines are parallel, they have to have the same slope. So I'm going to look for the slope of AB. So it looks like I'll start here, go up 1, 2, to the right 1, 2, 3, 4, 5. So my slope for AB is 2/5. So now I got to check CD. I got to see if that is 2/5. So I start here, I go up 1, 2, 1, 2, 3, 4, 5, 2/5. Same slope, they are parallel. All right, second, I got to look at the slopes of AD and BC. So AD goes down 1, 2, 3, to the right 1, 2, 3. So -1 is my slope there. Looking at BC, I go down 1, 2, 3, 1, 2, 3, -1. Those have the same slopes. Those are in fact parallel. So I can say that since I have two sets of parallel lines, I can say that ABC is a parallelogram. And you could have used any other of the theorems. You could have used, you know, parallel lines and congruent lines, see if they were the same, or you could have measured out the diagonals to see if they bisected or whatever. And that is being able to prove that quadrilaterals are parallelograms. Hope this helps. Till next time.